Hi, welcome to the channel. My name is Wallace. Once again, thank you very much to everyone that has subscribed to the channel and also everyone that keeps sharing and commenting in these videos. This video is a continuation of the topic movement. If you have not seen the first video, please check out the link in the description below. In this video, we're just going to look at the graphs, and basically there are two graphs that you look at for N2 and N3. The first graph that you look at is the displacement versus time graph. Okay, so this graph basically you are just comparing the displacement against the time that was elapsing. Now remember graphs is just a graphical representation of data, so we can be observing the movement, and then for every time that elapses we record. So it will be the displacement, how much displacement do we have against time. So it is just an observation, then somebody is recording the data, and then that gets to be represented on a graph. So every graph, as long as we are representing it against time, it will always have time on the x-axis, on the horizontal axis. That's where our time will always be. Any graph with time will always be on the horizontal axis, and with time it only goes forward. Time will never have a negative direction because time will never go backwards. However, for the displacement, it will be in the y-axis. It can even be in that direction, either going in that direction or going in the negative direction. Okay, so remember, displacement is a vector quantity. So basically that is how our graph will look like. You're just collecting data. The best way to understand a graph is if we look at a question and we see how well we can understand this. However, there are just a few things, especially for the N2. The N2 are the ones that may come across this question regarding displacement and time graph. It's a simple concept anyway. Let's look at the question just to understand this concept. A car travels from A to B, where it stops. After a certain period of time, it reverses from C to D. Answer the following questions by making use of the given graph. So we have a graph below there. When we look at our graph, we can see that it has the displacement on the y-axis, and it is marked 20, we have 50, and then in brackets there it says meters per meters. So which means our displacement, or that 50, that's 50 meters, and the 20, that's 20 meters. Then on the x-axis, we have the time, and they have marked that the time is in seconds, which means we have 10 seconds, 20 seconds, and also 30 seconds. So for the first question, it says what time elapsed before reaching B? How much time elapsed before reaching B? So 10 seconds there. So for question 2.1, that will be, our answer is 10 seconds. So that is how easy it is. You just look at the graph and you answer the questions as they are. Then the next question, what was the average velocity of the car between A and B? So with the displacement time graph, basically they will ask you for the velocity, and it will be an average velocity. Remember, velocity is equals to displacement over time. Now in this case, we don't know what was happening between the first 10 seconds between A and B. Was it increasing its speed or was it slowing down? But according to what we know, we've just been given a graph and it shows a straight line from A up until B. So this will be called an average velocity. Average velocity will be represented with a bar on top, because we don't know exactly what transpired in that 10 seconds. We have not been told about acceleration or whatever that might have happened. So with this one, we can see that with our displacement, we just look after the first 10 seconds between A and B, our displacement was 50 meters. We divide by our time, which was 10 seconds. So therefore, our average velocity between A and B, it is an average velocity. Remember, it even slowed down until it stopped. So our average velocity will be just 5 meters per second. And then that's it. If you can look at the mark allocation, that's just like 2 marks, 2 marks. And this basically you won't find it in the N3 kind of question paper, you find it in the N2 because it is just too basic and they're just trying to see if you can analyze the graph and answer from the graph. Then the next question would be 2.2. 2.2, calculate the displacement of the car after 3 seconds. Okay, so in this case, this displacement that we're going to calculate is just an assumption because we are assuming that this velocity was constant. This average velocity may have been constant throughout the 10 seconds. So we're going to use the same velocity. However, we are calculating for the displacement. So if we play around with this, our displacement is equals to v times t. Now remember, velocity, we're using the average velocity. So we'll say 5 times 3 seconds, which will give us 15 meters. So this is just an assumption that we could have traveled 15 meters within 3 seconds because we are assuming that it was moving at 5 meters per second throughout the 10 seconds that it traveled from A to B. Then 2.3, 2.4, the question says, what was the duration of the car's stopping time? So with this one, it is not even a matter of calculating, but we're just looking at the graph where the displacement on the x-axis, when we look at, on the y-axis, when we look at the y-axis of the graph, there is no change in displacement. The vehicle is not changing where it is still at 50 meters from B up until C. That period from 10 seconds to 20 seconds, the vehicle is not changing its position, which means it is now still at the same position. So there is no movement at that point. So we can call that part, it is the resting position, and the duration was 10 seconds. Okay, so these are things that we need to note, is that on the displacement time graph, when the graph is rising, then there is displacement taking place. It is moving. There is movement taking place. But when the graph goes horizontal, then the object is not moving. It is at the same position. Remember, on the y-axis, that is your position there. It is your displacement on your y-axis. So when the graph goes horizontal, then it means there is no movement at that point. Alright, when the graph starts to rise again, then there is movement taking place. Or even if it may start to drop, like in our example, if it may start to drop, then there is movement that is taking place because it is now moving, but not in the same direction. It is not going further from your starting point. It is now turning back towards the starting point. If it reaches the zero line, then it has come back to its original starting point. Alright, so with the displacement time graph, it is very easy. You just observe, then you answer. It's just a few marks. And I repeat, it's just for the N2 kind of questions. The next question was 2.5. 2.5 says, what is the average reversing speed of the car? So when we look at that graph, the reversing means we are going or heading back towards our original place. We have changed direction. We are not moving further away from our direction, but we are moving back to our original position. So our reverse is only taking place between C and D, and that is a time of 10 seconds. Now the displacement that took place was, we moved from 50 until we reached 20. So the displacement that took place was 30. So we reversed for 30 meters under 10 seconds, and our reversing velocity, or our average reversing velocity, was 3 meters per second. Okay, 3 meters per second. That is basically our displacement time graph. There is nothing much that we can say about it, but it's just, you look at the graph, you observe, and you analyze, and you answer accordingly. Then our last question, 2.6, it says, what is the displacement of the car from A until the end of the journey? So our displacement, our total displacement, is where the graph ends. Where the graph ends. If we look at the graph, we have the 20 at D. D corresponds with 20, so our displacement was 20 meters. This is not the distance, but it is the displacement that the vehicle has moved, or the car has moved. So it went forward 50 meters, reversed 30 meters, and we are now at a displacement from the starting point to where the journey ends at 20 meters. And then the next type of graph that you'll be looking at is called the velocity time graph. Okay, with this we are comparing the velocity and the time. Then, like we said, time will always be in the x-axis, the horizontal axis. Then you have your velocity in the y-axis, your velocity in meters per second, your time in seconds. Then we have our velocity, whether positive side or the negative side. With the velocity time graph, the few things that we can know is that if the graph is rising, then it means there is acceleration taking place. There is velocity that is changing. So in this case, you may have a velocity time graph that does not indicate, it just shows a velocity maybe of 20. After 2 seconds, it is still the same. This does not mean the vehicle is not moving, but it is moving only at a constant velocity. So a velocity time graph, when the graph is rising, that means acceleration. When the graph goes horizontal, it means constant velocity. The graph is not, the velocity is not changing, but it is constant. The object or the vehicle is moving but at a constant velocity. If the graph starts to rise again, it means again acceleration. If the graph starts to drop from that point, then it is having a negative gradient, then this means it is deceleration. Now, I have not mentioned this before in my videos, deceleration, but it is just deceleration is a negative acceleration where it is now slowing down. Remember, change can either be increasing or we can be slowing down. So when we are slowing down, we are reducing the velocity, so it is decelerating or it is undergoing retardation in the velocity. So those are the terms that you might find. How to calculate for deceleration? It is the same way as we calculate for acceleration, only that when we calculate, we'll get a negative answer. That negative answer indicates to us that we were slowing down. If you get a positive answer, it indicates that you were increasing. As long as you make sure you use your final velocity and your initial velocity correctly, then your answer will tell you whether it was acceleration or deceleration. Now, one more thing I would like to mention on the velocity time graph is that if the graph goes into the negative direction, let's say this graph goes and then it goes into the negative direction, this means it has changed direction. If the vehicle was going, let's say, in the positive side, this vehicle was going in that direction. Then when the graph represents going down, it means the vehicle is no longer going that side, but the vehicle has changed. It is now going into the opposite direction. However, also on the graph, on the negative side, if it is rising, it is increasing in the values of the negative side. It means this is still acceleration, but in the negative direction, in the opposite direction. If it goes horizontal, again in the same way, it's a constant velocity, but in the opposite direction. It is no longer going to the right, but it is now going to the left, and it has maintained a certain velocity. So if it reduces now and goes back to the zero line, then this means it is what? Deceleration. Okay, so that is basically a few things that we need to know about a velocity time graph, in that in the positive side, it is in a certain direction, whether accelerating or decelerating, but everything happening in one, if it is in the positive side of the graph, then all of this is happening, the vehicle is moving in one direction, it is not reversing, unlike the displacement time graph where we saw even the reversing was represented in the positive side. When we look at the negative side, acceleration, as long as velocity is increasing in the negative values, then it is reversing. It only decelerates when it goes back to the zero position, which is our zero velocity. That is a velocity time graph. Then lastly, on the velocity time graph, there are a few things that they'll ask us, and one of them is the total displacement. So the area of the graph, the area under this graph, that was the displacement up to this time. If we want to include this, we can as well include it. But now this is a positive displacement, which means it was going in the other in one direction, going to the right. This direction will mean you are reversing, which means this will be subtracted from this displacement that was taking place in one direction. Basically, those are the things that we might come across, and frankly speaking, this should not be a very difficult question. Let's look at the question that might help us understand this in detail. Alright, so here's the question. It says a bus is moving with a constant velocity of 20 meters per second for 5 seconds and then comes to rest in 3 seconds at the robot which turned red. Draw a fully labeled velocity time graph of the motion of the bus over this journey. Alright, so we are asked to draw. We have been given a statement, the bus is moving at a constant velocity of 20, and then you are going to draw. So I'm going to draw a freehand drawing, but when you draw, use a ruler and you use a pencil. So you draw the velocity on the y-axis. We draw our time in seconds. You have to indicate the values that you are using. Our time is in seconds, our velocity is meters per second. This is our 0. This bus, we can say 5, 10, 15, 20. Okay, so when you draw, like I said, you draw with a pencil, you make sure the distance or the demarcations of 5 seconds are equally spaced. I am drawing freehand, so my drawing might not be as accurate as it's supposed to be. And then on our time, I will say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we'll say 2, 4, 6, 8. Alright. So this, from the question, what we have is we are told that a bus is moving, so it is already, by the time we start observing this bus, by the time we mark our time of say 0, this bus is already at 20. Then after 5 seconds, it is still, after 5 seconds it's still at 20, so which means for 5 seconds, it means for 5 seconds from this 20 up to there, up to our 5, here's our 5, 1, 2, 3, 4, 5 seconds, up to there, straight line with a ruler, it shows that it was moving at a constant velocity. Whether we choose to check on 1 second, it will be at 20, at 2 seconds, it will be at 20, at 4 seconds, it will be at 20. Then we are told that it comes to rest. It comes to rest. Rest means there is no movement. The velocity has come to 0. In how many seconds? It comes to rest in 3 seconds. So in 3 seconds, we count time going forward. We won't count going backwards to say 1, 2, 3 since it came to rest. No, our graph will not go in that direction, but our graph will go up until it reaches our 8 and it has come to rest. So this is how our graph, or something like that, like this, that is how it should look like, and they'll give us all our marks for this. And then the next question, if we have drawn that, the next question will be calculate the acceleration of the bus during its last 3 seconds. Now, from the statement, we know that the bus was not accelerating, but it was decelerating. It was reducing its velocity until it comes to rest. So, acceleration, we are now answering 1.2.2. Our acceleration is equals to v minus u over t. our final velocity was 0, our initial velocity was 20, because that's where we're starting from. Initial was 20, then it goes down to that. We are dividing by the time. Do not use the 8 seconds, only use the time within which it was slowing down. From 0 up until 5, it was not slowing down, it was moving at a constant velocity. So our time is 8 minus 5, which is a 3. Our time will be 3 seconds, and then if we calculate using that graph, we find that it will give us 6.66 when we round off meters per second square, and that is a negative. To give us a negative 6.667 meters per second, which means it was reducing and not increasing in its velocity. So this, since they've asked you for acceleration, you can leave your answer as a negative answer, or you can say, since you know that a negative acceleration means deceleration, you can equals to 6.667 meters per second square. Okay, so if I call it a deceleration, I remove that negative sign. It is now just the deceleration represents a negative sign, but if I call it acceleration, I have to indicate a positive sign. Alright, our next question, the next question reads, calculate the displacement covered by the bus throughout the journey. So like we said, the displacement is this entire area. Displacement on a velocity time graph is equals to the area. So now if we divide this graph, we'll see that there are two shapes. There is this rectangular shape that is formed. We calculate for the area. Then there is this other shape that is formed, which is a triangle. We calculate for the area. Area of the triangle, that is half times the base times the height. Area of a rectangle, it is L times B. So to answer the next question, we'll just add up everything. Let's create some space there. 1.2.3, we're going to say L times B plus. So what we have is the length, we have 5, times the breadth, we have 20, plus half times the base. Now the base is only 3 times 20, our height of this triangle. Okay, so if we calculate that, that's 100, that's a 30. So what we have is 130 meters. That was the displacement throughout the journey. Then the last question says calculate the average velocity. Now average velocity, remember, like we did in the previous graph, average velocity, we are just assuming that throughout the 8 seconds it could have been traveling at this velocity without slowing down or without increasing. So with average velocity, that's our last question, 1.2.4. It says average velocity. Remember what we said, average velocity, we put a bar on top to indicate that it's an average velocity. You would take the total displacement, which means our 130, we divide by the total time, which is 8. We are taking the total displacement and we take the total time. So which means if our total displacement was wrong, even our average velocity is going to be wrong. Remember what I said? Everything is connected. So your answer in the previous one, we might need it in the next question. So after we divide that, it will give us 16.25 meters per second. So if we look at this observation, there is no one point where this vehicle has moved at 16.25. 16.25 might be somewhere here. This is 15. 16.25 might be here. So according to this average velocity, it means for the period of 8 seconds, we are assuming that we are moving at that velocity for that whole period. But when we look at the real graph indicates that we were moving at 20 for 5 seconds, then the other 3 seconds we were slowing down until we reached our point of rest. But this 16.25 is just an assumption to say, okay, regardless of what was happening, whether you are increasing or slowing down, in the period of 8 seconds, we are going to assume, or we are going to take it that you are moving at an average velocity of 16.25. Alright, I hope you find these videos helpful in answering your in your studies and in also answering your exam. My point again is practice a lot of questions. If you have any comments or any questions, you can drop them in the comments below and I'll be glad to respond to you.